We were promised a revolution. For the last decade, the smart home industry has sold us a vision of a sentient ecosystem. A home that anticipates your needs, lowers your bills, and manages your comfort perfectly. And at the very center of this vision sits the gateway drug to home automation, the smart thermostat. With their sleek glass interfaces and Wi-Fi chips, these devices promise to relegate the drafts and overheating of the past to the dustbin of history. But for millions of you watching, the reality is a bit different. Maybe you've woken up at 3 a.m. freezing because a motion sensor decided you didn't exist. Maybe you stared at a utility bill that refuses to go down despite using eco mode. Or maybe you are stuck in an endless loop of adjusting the dial because 22 degrees feels fine one day and freezing the next. Here's the uncomfortable truth. Most smart thermostats aren't actually smart. They're just remote-controlled switches with a digital veneer plastered over control logic that hasn't fundamentally changed since the invention of the bimetallic strip. In this video, we are going to tear down the invisible struggle of residential climate control. We will look at the physics of why your home is uncomfortable, the genuine danger of using smart vents, and why 22 degrees is a lie. Then we're going to look at the actual revolution happening in engineering labs right now, moving from reactive rules to model predictive control powered by generative AI. To understand the future, we have to understand the failure of the present. Despite the cloud connectivity, almost every thermostat in existence operates on a feedback loop known as hysteresis, or bang-bang control. It works like this. You set your heating to 22 degrees, roughly 72 degrees Fahrenheit. The system doesn't just hold that temperature. To prevent your boiler or furnace from cycling on and off rapidly, which would damage the hardware, the thermostat uses a swing band. It waits until the room drops to say 21 degrees Celsius, turns on the heat, and doesn't cut it off until it hits 23 degrees Celsius. This creates a continuous oscillation. You are too cold, then the heater blasts until you are potentially too warm, then you drift back into the cold. This isn't climate control. It's climate correction. This gets significantly worse if you have a system with high thermal mass, like hydronic radiators or underfloor heating. These systems retain huge amounts of energy. Even after the thermostat clicks off at 23 degrees Celsius, the hot water in the floor keeps radiating heat. This causes a phenomenon called overshoot. Users with radiant floors often see temperature swings of 3 degrees Celsius or more. The room remains uncomfortably hot long after the system has supposedly turned off. Not only is this uncomfortable, but it is also incredibly wasteful. HVAC systems operate most efficiently at steady states. This constant ramping up to recover from a temperature deficit and then overshooting represents a massive energy penalty. Your smart thermostat is essentially driving a car by slamming on the accelerator and then slamming on the brakes over and over again. Then there is the single-point sensing fallacy. Most thermostats are installed in a hallway, a transit space that nobody actually lives in. This single data point forces the system to make global decisions based on irrelevant local data. Because of the stack effect, buoyancy causes warm air to rise. Your upstairs bedroom might be sweltering in the winter, but because the hallway thermostat downstairs is satisfied, the heating cuts off. Or, south-facing rooms absorb solar radiation and become heat islands that the central sensor simply cannot see. Now you might be thinking, I'll just buy those smart vents that open and close automatically to zone my house. Please be extremely careful. Retrofitting smart vents can be dangerous for your hardware. Your blower motor is designed to push against a specific resistance, known as external static pressure, usually around 0.5 inches of water column. If you close multiple vents to redirect air, you spike the static pressure inside the ductwork. This forces the blower motor to work against greater resistance, increasing amperage draw and shortening the motor's life. But it gets worse. In heating mode, restricted airflow can cause the heat exchanger to overheat. The repeated expansion and contraction can lead to cracks. A cracked heat exchanger can leak carbon monoxide into your home. Or, in cooling mode, insufficient airflow can freeze your evaporator coil, potentially destroying your compressor. While some smart vent systems try to use algorithms to prevent closing too many vents, the risk of retrofitting zoning is a contentious issue among HVAC professionals for a reason. Even the software features we do have, like geofencing, are plagued by what experts call a friction gap. Geofencing is supposed to turn the heat down when you leave, but in practice, users report cold home syndrome. The system often suffers from latency. It only realizes you're home when you pull into the driveway. The HVAC system has had zero lead time to warm up the house, so you walk into a freezer. And don't trust the motion sensors either. These use passive infrared technology, which detects movement, not presence. If you are reading a book, watching a movie, or sleeping, you are motionless. To the sensor, you are invisible. This leads to false away events, where the heating turns off while you are asleep. Because of these failures, up to 50% of users in some demographics disable the learning features entirely, reverting their expensive device to a simple manual thermostat. But the biggest failure is the number on the wall. We are obsessed with air temperature, but according to ASHRAE Standard 55, human comfort is actually determined by 6 variables. Your thermostat ignores almost all of these. It specifically ignores radiant temperature. If you are sitting near a large cold window, your body radiates heat toward that cold surface. You will feel cold, even if the air temperature is 22 degrees Celsius. Furthermore, we ignore adaptive comfort. Research shows that our preferences drift. When it is hot outside, we are naturally comfortable at warmer indoor temperatures. By rigidly holding a static number, like 72 degrees Fahrenheit year-round, we are fighting our own physiology and wasting energy. So, how do we fix this? We need a paradigm shift from reactive control to model predictive control, or MPC. Imagine driving a car. Current thermostats are like driving while looking in the rearview mirror. You only turn the wheel after you've hit the curb. MPC is driving while looking through the windscreen. MPC uses a mathematical model of your specific building. It looks at a prediction horizon, usually the next 24 hours, and solves an equation to minimize cost and discomfort. For example, MPC sees a weather forecast predicting bright sunshine at 10 a.m. A normal thermostat waits for the room to get hot, then panics and turns on the AC. An MPC controller anticipates that solar gain. It creates a plan to reduce heating before the sun comes out, preventing the overshoot entirely. It also enables peak shifting. If the system knows electricity prices spike at 4 p.m., it can pre-cool the house at 2 p.m. when power is cheap, using the house itself as a thermal battery to coast through the expensive period. The results are staggering. Meta-analysis of fields indicate that MPC strategies can reduce residential HVAC energy consumption by approximately 40% compared to standard rule-based control. So why isn't this in your house yet? Because building a physics model of a house is hard. You need to know the R values, insulation thickness, and thermal mass. But this is where artificial intelligence and generative AI come in. We are moving toward cognitive thermostats. Using machine learning, these devices can learn the thermal properties of your home just by observing how fast it heats up and cools down. Even more exciting is the potential for generative AI. Imagine taking a few photos of your rooms and uploading your floor plan. An AI could instantly analyze the window-to-wall ratio and insulation type to create a digital twin of your home. This allows the MPC algorithms to run a simulation of your house, testing millions of strategies to find the perfect balance of comfort and savings. We're also seeing the rise of deep reinforcement learning. Instead of programmed rules, the AI plays a game where it gets points for keeping you comfortable and saving money. It learns strategies that no human engineer could program, like adjusting for a clogged filter or a drafty door automatically. And with the new Matter connectivity standard, this intelligence can happen locally in your home. This is crucial for privacy. With Matter, your data doesn't have to go to the cloud. The thinking happens on the device. Meaning, if the internet goes down, your smart home doesn't become stupid. The device we call a thermostat, a static wall unit that maintains a fixed temperature, is becoming obsolete. The inefficiencies of hysteresis, the discomfort of single point sensing, and the frustration of manual scheduling are not inevitable. We are moving toward a future where the interface disappears. A predictive cognitive climate system that knows the physics of your walls and the preferences of your metabolism. The ultimate goal of climate control technology is for you to forget it exists. The struggle shouldn't be managing your thermostat. The system should simply work. Thanks for watching.